Hello engineers, this is one mechanical engineer, and if you are preparing for engineering service examination, then this video will be very helpful to you. In this video I will discuss about condition of maximum work of gas turbine power plant, and I will also discuss formula to find maximum thermal efficiency of gas turbine power plant, and I will also discuss work ratio and air rate. So without wasting time, let's get started. This is the formula of thermal efficiency. So this is something which I derived the last time in my video. So in this video I will derive the equation for condition of maximum work. First I will explain condition of maximum work. So what is the condition of maximum work? Condition of maximum work is dW net, net work done, upon pressure ratio is equal to 0. So first I have to find out net work done. So what is net work done? Net work done is work done by turbine minus work done by compressor. So work done by turbine is Cp T3 minus T4. This is the temperature in the combustion chamber and this is the temperature in the turbine, and with net work done in the compressor is Cp T2 minus T1. So I have to find here value T4. I want the value of T4 and T2. So I will write here Cp T3. So I can take the value of T4 from here. This is something which I derived the last time. T3 is equal to T4 Rp raised to gamma minus 1 upon gamma. So if I will take T4, then this equation will be written as T4 is equal to T3 upon Rp raised to gamma minus 1 upon gamma. So this will become T3 upon Rp gamma minus 1 upon gamma. Minus CpT2 minus T1. Now I want the value of T2. So T3 minus T3 Rp raised to gamma minus 1 upon gamma minus Cp, and I can take the value of T2 from here. This is the value of T2. T2 is equal to T1 Rp raised to gamma minus 1 upon gamma. So I will simply write here, where is the value of T2? T1 Rp raised to gamma minus 1 upon gamma. Minus T1. So this I can take here T3 common. So this equation will become Cp T3 1 minus 1 upon Rp gamma minus 1 upon gamma minus I will take here T1 common. Cp T1 Rp gamma minus 1 upon gamma minus 1. T1 was common here. So this is the net work done. I will consider this as equation 1. So I will put this value in here. So this equation can be written as d upon drp cpt3 minus cpt3 into I will take this up. So this equation will become Rp raised to minus gamma minus 1 upon gamma. Then this will stay as it is. Minus CPT1. is equal to 0. So I will differentiate this equation with respect to DRP, with respect to RP, and there is no RP here, so this will become 0. CpT3 will become 0. And there is one formula of differentiation. This is the formula of differentiation. I will apply this formula right here. So this will become, this will come here, this is the n in this case, and RP is x, and gamma minus 1 upon gamma is n. So this will become like this, minus gamma minus 1 upon gamma minus 1, and then CpT1. So this can be written as, I will apply same formula right here, CpT1 into gamma minus 1 upon gamma RP gamma minus 1 upon gamma minus 1 minus CpT1 is equal to 0. So I can write this equation. I will cancel gamma minus 1 upon gamma minus 1, this and this from entire equation, and there is no RP here, so this equation will become 0. I done here mistake, sorry. So this can be written as CpT3 RP. I will do some here calculation. This will become minus gamma minus 1 plus gamma upon gamma minus CpT1 RP. This will become gamma minus 1 minus gamma upon gamma is equal to 0. I will cancel the Cp from this equation. T3 RP minus gamma minus 1. So in this case gamma will cancelled, so I can write here minus 1 upon gamma, and T1 RP minus 2 gamma minus gamma. Actually I have done some mistake here. Actually this will stay minus, this will become plus. Let me do this so you can understand it properly. So this will become, let me write this equation again. So I will rewrite this equation. I will cancel the Cp. So this equation will become Cp. I will cancel Cp, so I will write here T3 RP minus gamma means minus 2 gamma plus 1 upon gamma minus T1 RP. Gamma will be cancelled here, so this will become minus 1 upon gamma is equal to 0. So this is the equation which we get from here, and this equation can be written as T3 upon T1 is equal to RP raised to minus 1 upon gamma upon RP raised to minus 2 gamma plus 1 upon gamma. I can write this as RP raised to 2 into gamma minus 1 upon gamma. and I can write this equation as T1 upon T3 raised to 2 into gamma minus 1 upon gamma. I have done some mistake here. I can write this equation as 1 upon Rp is equal to T3 upon T1 raised to 2 gamma minus 1 upon gamma, and this can be written as so I will write this equation as three. This is equation 3. This is 1. So I will write here this is equation as this equation is equation number 2. So what this equation shows? This equation shows pressure ratio Rp. This is Rp, pressure ratio. Is Rp for maximum work. Is function of this is the limiting temperature or function of limiting temperature. In most of cases, T3 is the maximum temperature and T1 is lowest temperature. Now I will discuss about maximum work. So for maximum work, I will put the value of Rp T3 minus T1 per R3 is equal to Rp is equal to T3 upon T1 raised to 2 gamma minus 1 upon gamma. I will put this equation in this equation. I will put here value of Rp. So this equation will become W net, net work done, CpT3 1 minus 1 upon, then I will write here T3 upon T1 value of Rp, T3 upon T1 raised to gamma minus 1 upon gamma, gamma into 2 gamma minus 1, gamma minus 1 upon gamma, 2 gamma minus 1 upon gamma. Actually I have done here some mistakes. Actually 1 upon Rp is equal to T3 upon T1 is equal to 2 raised to gamma minus 1 upon gamma. So this equation cannot be written like this. This equation can be written as Rp is equal to T3 upon T1 gamma upon 2 into gamma minus 1. So this is the value of Rp. So I will put this equation in this equation. So I have done some mistake. So I will write this equation again. W net is equal to CpT3 1 minus 1 upon T3 upon T1 raised to gamma minus 1 upon gamma into gamma upon 2 gamma minus 1. And then I will write here minus CpT1 into Rp. Value of Rp is T3 upon T1 and again gamma minus 1 upon gamma into gamma upon 2 gamma minus 1. So here gamma will be cancelled, this gamma will be cancelled, gamma minus 1 will be cancelled, gamma minus 1 will be cancelled. Same will happen here, gamma minus 1 will be cancelled, gamma and gamma will be cancelled. So this equation can be written as W net is equal to CpT3 into 1 upon T3 upon T1, 1 upon T3 upon T1, and here gamma minus 1 is cancelled, gamma is cancelled, so this will be written as 1 upon 2. And then minus CpT1 T3 upon T1 raised to one upon 2. So this equation can be written as CpT3 1 minus 1 upon root 3 upon root T1 minus CpT1 root T3 upon root T1. This equation will become 1 minus root T1 upon root T3. This will go upside. This is simple mathematics. CpT1, this will stay as it is. Then this will be multiplied, root T3 will be multiplied with root 1. 1. This will be multiplied with 1. Then I will write here 1 minus then actually I have done some mistakes. Actually I forgot to write here minus 1 minus 1 minus 1 minus 1 minus 1 minus 1. So the same thing will happen there. Root T3 minus root T1, because root T1 is multiplied here to the 1 upon root T1. Then this equation can be written as Cp root T3, this is simple mathematics. I hope you all know. Cp root T1 and I will multiply this with T3. T3 will become T3. Root T3 into root T3 is equal to normal T3 minus Cp root T1 minus root T1 into T3. This will also stay Cp root T1 into T3 minus Cp T1 root T1 into root T1 is equal to T1. So this equation can be written as Cp into T3 minus root T1 T3 minus Cp into root T1 T3 minus T1, and this can be written as Cp T1 plus T3 T1 minus plus T3 minus 2, so it will become minus 2 T1 T3 inside of root. This is the maximum work. This is maximum work. I will call this equation 3, and this equation shows that maximum work is dependent on limiting temperature range. T1 and T2, T1 and T3. Now I want to discuss about thermal efficiency. This is maximum thermal efficiency. So for that I have to tell you few things. I will take another page. First I have to consider here air and fuel passing through open cycle gas turbine power plant. So mass of the air will become Ma. This is the mass of air supplied to combustion chamber. Mass of air supplied to combustion chamber. Which is kg per second. Which is in kg per second. And specific heat of gas, CPG. This is specific heat of gas and specific heat of air, because in the combustion chamber air and fuel will be mixed up. That's why I am taking specific heat of gas and air both. So net work done in the turbine is mixture of air and fuel. So I will take here mass of air and mass of fuel both, and Cp G specific heat of gas into T3 minus T4, and net work done by compressor. In compressor there will be only air, no fuel and gas, so I will write here Ma Cpa specific heat of air into T2 minus T1. I will take a look of network done by turbine by open cycle gas turbine, which is network done by turbine minus network done by compressor. So this equation can be written from these two equations. MF value of work done by turbine, I am taking this from here. Minus MSCP, I am taking value from here, network done by compressor. Now I will take a look, this is the network done by the turbine. Now I will take a look at heat supplied. Heat supplied to combustion chamber. Which is Qs, this is heat supplied, mass of fuel into calorific value, and combustion efficiency, this is the combustion efficiency. Let me write here Cv is equal to calorific value fuel, and this is the combustion efficiency. In this case we are talking about maximum thermal efficiency, so thermal combustion efficiency will be 100%. So neglecting the heat losses in combustion chamber, so we will take the efficiency as 100%. So this equation can be written as like this, because this will stay 100%. Formula to find thermal efficiency is so W net is equal to, this is the W net, so I will write this and the value of Qs, this is heat supplied. This is the maximum thermal efficiency. This is the formula to find the maximum thermal efficiency of open cycle gas turbine. Now I will discuss about work ratio. So what is the work ratio? This is the ratio of net work done to work done by turbine. This is the ratio of, this is called work ratio. Let me write here definition. It is the ratio of work produced by plant to turbine work. And there is one point which I want to tell you. The work ratio represents the amount of work generated by gas turbine plant per unit turbine work output. And this question was asked in engineering service examination, so that's why this is very important if you are preparing for engineering service examination. So let me write this equation. Work ratio is equal to net work done upon turbine work. So net work done is work done by turbine minus work done upon by compressor and work done by turbine. This can be written as 1 minus WC upon WT. Then this equation will become 1 minus work done by compressor is T2 minus T1 and work done by turbine is T3 minus T4. And again I will take here the value of T2, and value of T2 is this is the value of T2, T1 Rp gamma minus 1 upon gamma. So I will write here T1 Rp gamma minus 1 upon gamma minus T1 upon T3 minus T4. So what is the value of T4? So this is the value of T4 which I have already derived, T3 upon Rp raised to gamma minus upon gamma. So final equation is 1 minus T1 upon T3 Rp raised to gamma minus 1 upon gamma. This is the final equation of work ratio. And work ratio increases when turbine inlet temperature increases, and work ratio increases when compressor inlet temperature decreases. Work ratio increases when pressure ratio of cycle decreases, and maximum inlet temperature, actually compressor inlet temperature is atmospheric pressure in case of open cycle gas turbine, and it is 1000 Kelvin This is the highest temperature which was taken in the mechanical history. So we never took more than 1000 Kelvin as inlet temperature in the compressor, and there are lots of metallurgical reasons behind this, because material of compressor might not be able to take that much temperature, so we don't take more than 1000 Kelvin in the compressor as an inlet temperature. Now I will talk about air rate. This was also asked in engineering service examination. First thing I want to tell you is size of plant depends on rate of flow, rate of air flow in relation to net output work. Compact turbine plant has lower air rate. And air rate is expressed as kg of air per kWh. So let me write here equation of air rate. Air rate defined as kg of air taken per hour upon power output in kilowatt. So kg of air taken per hour is mass of air into hour, means 3600 seconds, and power output means mass of air into net work in kg per kilojoule per kg, kilojoule per kg. So this can be written as 3600 Wt minus Wc, net work done by turbine minus net work done by compressor, into kg per kilowatt hour. This is the mass of air. Let me write here m is equal to mass flow rate of per second. This is it for today. God bless you.